Welcome to BrainStorm 9000.
Welcome, dear listeners, to BrainStorm 9000, the podcast where we talk about brains and minds and all the things that affect them and ways to help them and so much more. I'm Master McMaster, a human and a philosopher, and also sometimes a crazy person. And of course, I'm here with Dr. Schultz, esteemed psychiatrist. Welcome, Dr. Schultz.
Greetings, Earthlings.
And today we are going to have an enlightening conversation about this really cool technology called Neurobiofeedback.
Actually, anytime anybody has any conversation or any human activity, we also have together with us a lot of invisible people and creatures. So today, like for example, periodically you would think about your family, your friends, something comes up, like a song or something. So we always have in our mind a lot of folks. But today, we have pets in this room. Cats in particular.
There is also a very special human here.
You are talking about Andrew? Hi, Andrew.
Good afternoon.
So Andrew Setter and I go way back, like 7-8 years ago, when we worked together in the department of neuropsychiatry in one of the hospitals, where I was playing a role of a medical director, and Andrew was in charge of, you called it...
Very complicated name.
Yeah.
We called it neuromodulation and neuroassessments.
Okay, so what it meant that you were doing quantitative EEG,
Exactly.
neurobiofeedback,
Correct.
so you are a super expert.
Correct. So biofeedback is a big part of what I do and what I've been doing for about 15 years now, working with anyone along the age spectrum, from little tiny children to older adults, doing both neurofeedback as well as HRV biofeedback.
What is HRV?
HRV is heart rate variability biofeedback.
Okay, we'll talk about
Something
it.
we can talk about separately.
Yeah.
No, we'll talk about the whole 9 yards here. Well, why don't we say what neurobiofeedback is?
Sure.
Andrew, give it a shot.
I'll take a stab at it. now.
Okay.
Neurofeedback is a form of brain training that allows people to manage and improve symptoms that are brain-based. So things like anxiety, depression, ADHD can all be rooted in the brain and usually a dysregulated EEG profile. The neurofeedback is a form of training that will improve the regulation of the brain and hopefully alleviate symptoms.
It's based on a very well-known phenomenon, that's a big word, which is called operant conditioning.
Yes.
So a good example of operant conditioning is, for example, when a child reaches out to get something and the mother yells, "Don't touch it." Let's compare it to classical conditioning. Classical conditioning was discovered by Pavlov with his famous Pavlov dogs. Pavlov was a Nobel Prize winner, but actually received his Nobel Prize for his work in the physiology of the digestive system, and he was conducting a lot of experiments. He developed a method of measuring the amount of saliva a dog releases. Dogs are very interesting animals for this purpose because they normally don't salivate. If you see a dog running around the street with its tongue out, releasing a lot of saliva, it's not saliva. It's actually sweat. They sweat through their tongue. They don't have a capacity to sweat through their skin. So they don't normally release saliva unless they are in front of food or are eating food. So it's very easy. You give the dog food, it releases saliva, you can measure it using special methodology. Pavlov noticed that if the sound coincides with food presented to the dog, of course releases saliva, and then if you just sound a bell, for example, the dog will release saliva. So this is called classical conditioning, when there is an actual physiological stimuli, food, right? And then there is a response. Food, saliva. Operant conditioning is when there is no actual physiological thing going on. It's, for example, red light, don't cross the street, right? Probably a number of people tried to cross the street and got hit by a car and died, but I doubt it. It's just we decided, right? Green, you go, red, you stop. Or if your mother yells at you, don't touch, it's a very good idea not to, especially if your mother is Russian. Or Italian.
Or Italian, I was going to say, those wooden spoons.
For you, right?
No bueno.
Right. All right. We are not teaching anybody to abuse children here. So, Andrew, so please continue. So how does it happen?
So it simply happens on a feedback loop with the brain. Technology can measure brain activity in real time, and a computer will determine based on those measurements whether your brain activity is, we can say, healthy or not healthy. And when it's healthy, the computer provides the patient or the person with feedback. Usually it's in the form of a visual light or an animation, something that tells them that you're doing well, tells the brain that it's performing well. And it's actually a very subconscious process. So a person does not have an active control per se over that feedback activating. They can't make it happen.
So, Master McMaster, please enlighten us. How did it all come about?
Yes, this is my favorite part and probably the only thing I can contribute to this conversation. Here we have two amazing experts in the room, but I, ladies and gentlemen, and everything in between, am the cat expert in the room.
Right.
So let me tell the very interesting story of how this was all discovered. So in 1965, a scientist named Barry Sturman was conducting experiments about sleep, and he was using kitty cats. Before everyone starts crying and getting really upset, because I was shocked my first when I heard that they were using cats, but apparently that was a thing in the 60s, and there are reasons. So one is that there was such an overabundance of cats that they were being euthanized left and right. So it was like, why not use them for this?
And save their life.
And yeah, you save their life. And another reason why they decided to use them for this study is because they were much easier to use than dogs, because they were all roughly the same size. All their brains were roughly the same size. And Barry Sturman, in these interviews, will tell you that they treated the cats well. They were excited. So they were basically they plugged in an EEG into the kitty cat brains to measure their response. So first they were doing a Pavlovian kind of thing where they would put them in a little box, there would be a little lever, and if they pressed the lever, then they would get a reward, which was a savory mix of milk and chicken broth. So the cats, when they press the lever, they get a treat. And Sturman was like, all right, let's take this up a notch. So they started pairing it with a tone. And what they would do is they would make it so that when they press the lever, a tone would sound and, for a specific amount of time. And when the tone was done sounding, then the treat would come about. And cats, being the lovely, amazing creatures that they are, were like, fuck this. I'm not going to sit and wait around for where's my treat? So while they were waiting for the tone to be over, they were just chilling, getting into that kind of state that we see most house cats in, where they're very calm and very still, and they kind of look like they might be sleeping, but they're actually very alert. And it's kind of like their Zen hunting mode, which is what cats are in most of the time when they're actually awake. And they noticed when the cats were in this state, they had a very specific kind of brain wave pattern going on in their brain. It created what's called spindles, and it was between, it was a specific frequency of electrical activity in the brain. So they wanted to see if they could possibly train the cats to induce that state. It's thought that you don't have control over that kind of thing. So the idea was, let's see if we can train them to just do that on their own. So eventually they started doing it so that the cat would just be chilling. And once it was in that state, that 12 to 15 hertz, that sweet spot,
SMR rhythm.
SMR rhythm, yes, then they would get their treat. And eventually they got really good at it and they could just do it and then they would get their treat. And then they were like, holy shit, animals can change their brainwaves.
So they were trying to basically redirect the cats from responding to classical conditioning food directly to the operant conditioning stimuli, the sound. In the process, they discovered that they go into a particular state of their brain activity. And then they again paired it with a classical reward, food, right? So for the cats, the whole training had to do with classical conditioning. You get the spindle, we give you cat food.
So they got the cats to a point where they could self-induce this state of spindles.
Right.
And then, the study was kind of over. But later, Sturman was pulled into another experiment where, unfortunately, they were injecting the cats with rocket fuel to try to test the effects because, people were going into space and rocket fuel was making them sick. So they were trying to test it on cats to figure out a solution. And when they injected the cats with rocket fuel, the reaction for almost all of the cats was nausea, vomiting, and seizures. And they noticed that there were a couple of cats for which the seizures were much more delayed than the other ones. And for a smaller amount of cats, they didn't have seizures at all. And then they were like, what the hell is going on with these special cats? And they realized that those cats were the ones from Sturman's initial experiment and that they were able to basically train their brains using the operant conditioning from his initial study to strengthen their brains and make them more resistant to things like seizures. And then they were like, oh shit, maybe this can work for humans. And maybe let's see how it works when it comes to like epilepsy in humans.
And that's how it all started.
And that's how it all started. So, Andrew, can you tell us a little bit more about how this works in humans?
Sure. I think now one of the key features from when Barry Sturman first realized this was capable of happening is that now we can map the brain.
Right.
And we can assess your EEG in a quantitative way, so a normative database comparison, and determine how deviant your brain activity is and where. So now we can really target neurofeedback for very specific areas and frequencies. And for people, now we can work on any host of brain-based illness. If you name it, if it's based in the brain, we can work on it and train it. Things from mild sleep issues or mild stress to more severe issues like autism.
Or even we had a client who was in his early 20s who had cerebral palsy. So just for people to understand
wow.
what it is, when a person gets born, sometimes they get hurt and they develop multiple neurological issues. So it's like brain trauma. It is brain trauma, but at a very early age. He, for example, couldn't read and was extremely shy. So after about session number 15, he started learning how to read.
Wow.
And he also started making attempts to make a date with our front desk girls. I was stunned actually by this experience. And Andrew probably had significantly more experience working with traumatic brain injury patients, TBI, right, Andrew?
Sure, absolutely.
So what did it do for them?
It can do a variety of things. When we talk about head injury, anything from a concussion in sports to a car accident to a fall or fight can result in a head injury. And oftentimes it can span many years where people don't realize the impact on the brain. It can result in things like inattention, poor focus, things like memory loss, even chronic pain types of symptoms.
Or getting angry very easily.
Irritable, sure. Mood issues. So, working with folks like that, it's rewarding when you can see them return to more of a baseline or improve their symptoms. For athletes, things like returning to play, having a clearer picture of the brain when it's healthy and it can go back to competition or sport versus it maybe being asymptomatic,
Right.
but still having residual effects in the brain that subjective testing won't assess.
A subjective meaning you ask people questions and they say everything is okay. But also people who have objective and subjective problems, it really works.
Yeah, so what kinds of other like mental health issues has neurobiofeedback been known to be effective on?
Well, ADHD, anxiety, depression, OCD.
Those would be some of the most
Right.
common for sure.
Autistic children respond pretty well. Again, Andrew actually worked with a little boy who was autistic and with ADHD with amazing results.
Yeah, I've worked with several. I used to be in a clinic where we actually specialized in autism spectrum issues. The expectation shouldn't be that we're able to cure autism. That word is a
Right.
very, you want to use that word carefully, but certainly improving symptoms and some very dramatically. We had nonverbal kids that would be able to speak after, again, 75 sessions. It took a lot more work, but parents would, hearing their child say things like, I love you for the first time,
Wow.
really opened your eyes to the impact you could have using this type of technology.
Yeah.
So in this room, we have a resident person receiving this kind of treatment.
Who? Oh shit! Yeah,
You
you're
won't
talking
know,
about
yeah.
me.
Master
Yes.
McMaster. So tell us about your experience. How does it go? Like what happens?
Yeah, so I can talk about I'm still in the early stages, so I can't talk about like results or anything.
Right.
But yeah, I've been trying it out. It's super cool, and I'm super excited to see what the long-term results can be. For my first session, Andrew did a quantitative EEG on me, so I got fun little cap that makes me look like a synchronized swimmer that has little electrodes all over my scalp, and squeeze a little bit of gel in there so that it can connect to the skin, which is much less messy and uncomfortable than it sounds. It's actually like very deal withable.
So we didn't have to shave your head after this.
No, and I have very long hair, so I was a little nervous, but it was great. So I had the EEG cap on, and I was basically given a series of like concentration type tests. Concentrate on this, keep your eyes closed for this amount of time, focus on this, respond to these stimuli. And Andrew could probably say more about the purpose of the test, but when it was over and all the data was synthesized, there was a brain map created for me in color that showed the different parts of my brain where the electrodes were measuring the electrical activity and what that activity was like.
Especially compared to women your age.
Yeah, so it was more, when it was more red, that's when it was too fucking overactive compared to other people my age, other women my age. And then the parts where it was blue, maybe a little underactive. And and we have a fabulous picture of this on our Instagram, BrainStorm 9000, and you can also see it on our website. It's super cool. So basically, what they did was they looked at my brain map and the different areas that say were super fucking red. And it's like, okay, this is a problem. And it's funny because then we looked at those, like where those correspond with areas of the brain and like kind of what they're known to be linked
Associated with.
Yeah.
Functional.
And those were things like
Executive functions like
Yeah.
attention, organization, maybe focus, things like that.
Yeah. And so for me, everyone knows I have anxiety all over the place. And lo and behold, the areas associated with like language, sensory perception,
Hypervigilance.
social interaction,
Sure.
hypervigilance, yeah, it was all like super red. So then we focused on those areas to quote train. And so when I go in for my session, they put on my little EEG cap and they set up a computer and it has a program that has basically a little circle, and the circle turns green when those overactive parts of my brain
Quiet down.
are starting to chill the fuck out. And yes, quiet down. And that's where, I want to be. So it's hard to keep it there. It's really hard to keep it green.
Have you felt the effects of a session after the sensors were taken off a little bit?
I definitely, after the sessions, I feel like calmer.
Okay.
I feel like a little bit more centered. I mean, you just, you look at the dot, and I've tried like actively to do different things. And there are things that I can like think about and focus on that will keep it green, but I know I'm just supposed to let my brain do the work, right?
Right. So a couple of things of notice. When the computer, so the electrodes don't measure anything. They send the signal to the computer, which streams them to a cloud, right, Andrew? And then,
For the assessment?
yeah.
Correct.
And then what happens?
So it's just like getting a lab test done, essentially. You're collecting different physiological measures,
Right.
and in turn, you're receiving back a lab report on what your brain is doing or not doing. And from there, you can make a lot of brain-based diagnostics and treatment choices.
Yeah. So somewhere out there, somebody compares Jane's EEG to a bunch, thousands of EEGs of normal people who are in her age group and who are female, because males have a probably different pattern.
Different profile.
So we get the comparison to what is considered to be normal because they collected a bunch of data. And then when Jane sits there and stares at the screen, once the brain produces randomly electric activity that is desirable in the area where it's not present, the green light shines. So this way, using operant conditioning, the brain, similarly to the cat's brain, learns to produce more. What happens, Andrew, if we have a child? Maybe green light is not such a cool thing for them?
That could be true. There are other ways to provide that visual feedback to the brain.
Right, like what?
Whether it's using different media files, like a movie,
Right.
that might play or stop playing depending on your brain pattern. But it's actually interesting for adults. The most effective connection for the brain is the simplistic light that turns on.
Yes.
You'll get the most immediate feedback into the brain with the simplicity of the light. When you start adding multiple components of feedback, the brain might have a more difficult or just take longer to process that feedback loop. So it's a highly effective form of feedback.
Yeah, so can we talk more about how this works? First, I would love if we could cover how brain waves are related to cognitive function in the first place.
Sure.
So the God's honest answer is, we don't exactly know.
Fair.
What is observed is this. When there is a particular frequency pattern in the recording, and it's prevalent in certain areas, it's most likely to mean certain states. And maybe Andrew can
Sure.
give us the rundown.
Sure. So, just like driving a car, our brain performs in both slow frequencies and fast frequencies. We want to drive our car or use our brain at the proper speed. So, for example, when we're sleeping,
Right.
we get into a very slow frequency called delta, okay?
When we fall asleep,
When we fall asleep.
then it all changes. Yeah.
Then when you're drowsy or daydreaming, there's what's called theta frequency, which is also considered a slow brain state. If you're more active and you're thinking, hopefully we're all in a beta frequency here, right? We're processing information, we're talking, we're carrying out different tasks, and beta is a faster frequency. So, obviously, those brain speeds correlate to behaviors and functions. You don't want your surgeon to be in a theta frequency when he's performing a procedure. And we don't want to be stuck in a beta brain state when we're trying to go to sleep.
Or meditate, which is alpha.
Correct. Or there's the alpha
Relaxation,
frequency.
yeah. Relaxation, meditation.
So our brains have this natural ability called state flexibility to shift between these brain speeds depending on what we're engaged in. Problems arise when that state flexibility is reduced, where the brain gets stuck in certain brain speeds.
Yes, we also need to understand that this conversation is a very didactic conversation. We are trying to make it simple. And the reason we are using quantitative EEG and the reason you have a cap all the time is because in different parts of the brain, at the same time, there could be different frequencies depending on what is going on. So it becomes very complicated. But the bottom line is that we know that if such and such activity is supposed to be present in the brain, it means that it's functioning all right. So on quantitative EEG, it's coded as green for a particular area. And what our machine is supposed to do for us is help our brain to realize, look, at this moment, you are doing beta, for example, but you need to be in alpha. Or you are doing alpha and you need to be in beta. Right?
Mm-hmm.
So what are the intricate mechanisms underlying the effect of neurobiofeedback is still to be found out. And I understand that people are beginning to work on Neuralink. Good luck to them and all the kudos to them. Maybe they'll enlighten us. Research is on neurobiofeedback is very limited at this point. I'm talking about expensive neurophysiological research.
Mm-hmm. So can either of you tell us a little bit about how exactly neurobiofeedback can help with different kinds of mental health issues like ADHD, for example?
Typically, again, if you want to first get the brain mapping, the assessment done, what we traditionally see for things like ADHD is a lot of those slower brain states that we talked about, those slower speeds in what's called the frontal lobe. The frontal lobe provides functions for attention and focus. So people that have trouble with attention and focus in ADD, their brain, their frontal lobe is usually producing too much of that slow activity. So what the neurofeedback can do is train the brain to reduce it, all right, normalize it.
So amazingly, for each disorder, there is a very characteristic pattern. Like, for example, if you remember, what Andrew said after he saw your quantitative EEG was extremely accurate. And when he came to work with you, he didn't know you at all. He still doesn't know you that well.
Mm-hmm.
So he immediately started talking about anxiety, remember?
Busy brain.
Busy brain, he said.
That's me. Yeah, so with neurobiofeedback, so you do X amount of sessions and it, retrains your brain
Think
to...
of it like exercise.
Yeah, to form different connections, stronger connections where you need them, etc. So how long are those results supposed to last for?
Results are permanent. When you retrain the brain, the results will stick. Now, does that mean that you won't need to come back maybe for what I can call a booster session or two every once in a while? Sure. Some people will come back when they feel a little off, so to speak, right? And they'll come back, kind of get a maintenance session or a booster type of session or two, and then I won't see them again for a couple of years or forever. So the results, it's fair to say, are relatively permanent.
So this could be something like an alternative to a lifetime of medication.
Sure.
Yes, everybody is hoping so.
That's so crazy. I mean, this whole idea, it's non-invasive. You don't have to take pills forever. Such an amazing treatment option. So why isn't it more popular? Why don't more people know about this? Because I didn't hear about it until recently.
You want a conspiracy theory or a thought?
No, I want what really happened.
First of all, the awareness is increasing tenfold every year. In 15 years of doing this, people have gone from, I've tried everything else under the sun, nothing works, to I want to try this now, to now so many people are coming in saying, I want to try this first. So the awareness is getting out there. Technology is getting better. Media is picking up on it more often. You're hearing more people's stories.
Mm-hmm.
Instagram and Twitter and YouTube. Now you can see a story or share a story instantly. So there's more exposure out there for what is happening in the field. Unfortunately, pharmaceuticals just have a very big stranglehold on mental health.
Well, we can
Ah.
blame everything on pharmaceuticals. I think their head is exploding right now because everybody talks pharmaceuticals. But if pharmaceuticals is smart, I have to tell you that people who initially started working with neurobiofeedback, I'm sorry to say it, were very nice people, well-meaning people, but not business people, and not people who understand very clearly what things are going to take and what things are going to be dismissed. So what happened was that people saw that if you start supporting lower frequency activities in the brain, like around, let's say, 4 hertz, I would say, all of a sudden people would go into a meditative state, and some would see Jesus, seriously, like meet the saints, basically have a very good time, almost like getting high. And it became, especially in California, extremely popular. And people started using these machines without quantitative EEG. Quantitative EEG is relatively new, right? Just making people basically to get kind of high on neurobiofeedback. Actually, it wasn't even the biofeedback. They would just induce these slow frequency states. And it started, so in the 60s and the 70s, it was probably cool. But then when Prozac came on the scene, it was 1988, so you need to remember, right? People started looking at it as some kind of, in quotes, crazy thing. And once bad publicity was done, it's very difficult to undo it. But you'd be surprised to find out that in a number of cases, especially when it comes to treatment of traumatic brain injury and some other neurological conditions, insurances actually pay for it.
Really?
Yes.
Okay.
So, but for a lot of cases, they don't. And actually, unfortunately, in my practice, I had a case when insurance initially approved the treatment, the client got better, and then they demanded that we return the entire sum of money that they paid us. And no matter how much client complained, and we did, they still took it back. So it's complicated.
So it's not super popular with the insurance company.
Not super popular, and that's why the majority of people who practice neurobiofeedback don't want to deal with insurance because, I mean, you spend your time and money, you buy relatively expensive equipment, you work, right, for your living, so you need to charge people. This is one of the barriers. I don't think that pharma plays a very big role in neurobiofeedback not being popular. It's just we also need to remember that in many cases when we presume something like that, actually clientele, I mean people who come for help, are not educated about it and want medication. In many cases,
It's the culture more
yes,
than it's.
in many cases people come to my office, I'm a psychiatrist, just to remind everybody, ask me for drugs. And when I tell them, look, there is a book on the shelf, this book, A Symphony in the Brain, is always on a shelf in a very visible position. I tell them, you know, there is neurobiofeedback, pick up the book and read. They say, no, I don't want to know about it.
Yeah.
So another reason we are having this program is to make yet another attempt to educate people,
Yeah.
all these 3 people that are listening to our podcast, to appreciate it better. Also, I have to tell you that neurobiofeedback, similarly to a lot of natural ways to treat people, is not in sync very much with the modern millennial lifestyle. People go out at least once or twice a week, and let's be honest, to get drunk out of their mind. So this is a very fine process. So somebody fine-tunes the machine and makes it run perfectly well. And then somebody sits behind the wheel and speeds up to 200 miles per hour and puts wrong gas in it. Of course, you have to tune it again. So it's a give and take process. I would say that the largest population on Earth who still benefit from this are children. Because hopefully they don't drink, they smoke pot, they don't smoke pot, they don't do drugs.
Not yet.
Hopefully never, right?
Yeah.
So to summarize, mistakes in the very beginning, not enough effort to make it popular, not enough effort to educate physicians to have it done. As we know with Andrew, most of the people who do it in their offices are actually psychotherapists, and they do it in combination with psychotherapy. Physicians are still very few.
Yeah, I was going to ask if it's like approved and accepted among physicians and psychiatrists, you know, in the medical community.
It depends. It depends. It's not rejected.
Again, the culture's changing. It's only moving forward. Devices are improving, technology's improving. It's making complicated neuroscience assessment and biofeedback tools more applicable to your general practitioner, to your neurologist, to any family practice doctor is beginning to see some access to this type of science.
Yes, and then maybe you can talk briefly about heart rate variability that you mentioned.
Sure.
That is even easier, right?
Yeah, that's a much more standard training protocol. You don't really have to customize it much for individuals. And the idea behind heart rate variability biofeedback is we get a window into the autonomic nervous system. And through respiration, we're able to stimulate and exercise the autonomic nervous system. So breathing at a very specific respiration rate, usually about 6 breaths a minute, will start to exercise and train your autonomic nervous system. So even things like anxiety or head injury can be correlated to heart rate variability metrics. So there is an impact not only in the brain, but the heart.
That's so cool.
And we can retrain that physiology as well.
Very cool.
Yes. So there is neurobiofeedback, and then there is biofeedback.
Mm-hmm.
And then people are also trained for different physical elements, right?
Sure.
Yes. So it's an up-and-coming area, and as a practitioner, I have huge hopes that I'll see the day when the majority of people are going to be able not to take their medication all the time. I have to deal with it every single day. Not a subject to psychotropic medications myself.
Yeah, I would
although-
love to not have to take medication every day.
Right.
I mean, it has side effects, it costs money, like there's a lot of reasons, why this is so preferable, which is why I'm so excited to see how this is going to turn out. So actually, if people want to tune in and follow this, we do sessions once a week and we put videos of it on our social media, our Twitter and Instagram. And you can also go to our website for some videos of this so you can kind of see what it's like. It's really interesting, and I will be reporting back about my results.
So
Excellent.
maybe on this positive note, we can say neurobiofeedback rules.
Neurobiofeedback rules!
Yeah.
All right. Yeah. Well, thanks, Andrew, so much for being with us today.
Thanks for having me. Happy to be here.
Yeah.
We're always
and,
happy to have you any
yes.
day of the week.
Signing off, BrainStorm 9000. Dr. Schultz, would you like to advise people to keep something open?
For now, keep your brains open to neurobiofeedback and to our podcast. Andrew, thank you very much for spending the time with us and enlightening all of us.
Yes.
Excellent.
Goodbye, Earthlings. Hey everybody, thanks for tuning in to another episode of BrainStorm 9000. If you like us, love us, or marginally tolerate us, hey, go ahead and subscribe, rate, and give us a review on iTunes or Stitcher or wherever the hell you listen to your podcasts.